Hello students, now we are going to understand integrations of class 12. It's a very useful subject and very scoring subject. So let us understand the basics and move. Let us go. See, this is based on paper 2B of Telugu Academy, class 12 maths, chapter 6. Okay, we are going to review this chapter, and through this chapter we are able to understand what is integration. Let us see what are the uses first, general uses. Suppose there is a rectangle. This is a rectangle. I want to find out the area. So we take a small strip x, width of dx. So what is the area of this strip? Y into dx. So area of the strip is y into dx, and such strips we are adding from 0 to a. So total area is integral. This is what we are looking for, integral. Integral y dx limits from 0 to a, because dx is varying from 0 to a. Here y is constant b. So integral b dx, that means b into x, that is a. So the area of rectangle is AB. It's very simple to understand. We know a into b is the area of rectangle. Let us see a triangle. Suppose this is y at a distance of x. What is this height? This height is proportional. So b by a into x. What is y here is b by a into x. So again the strip area is y dx. So b by a into x dx. And I want to integrate it from 0 to a. Integral y dx is integral b by a x dx. So what is integration of x dx? X square by 2. So when I substitute a here in place of x, this is a square by 2, it becomes half ab. So rectangle, area of a triangle is half base into height. This also we get from integration. Let us see a quadrant here. Y parabola. This is a parabola. So y is kx square. So AB, if when y is b, x is a. When I substitute there, when y is b, x is a, I am getting k is b by a square. Now what is here area of the small strip? Y dx. It's like a rectangle. Small strip can be taken as a rectangle. Height is y, width is dx. So integral y dx. Integral y is kx square. So integral y dx is kx square dx. K we know, b by a square. So b by a square, x square dx. This becomes b by a square into a cubed by 3. So 1/3 ab. So when we got the extreme figures, y is kx square is 1/3 ab. If it is kx cubed, 1/4 ab. If it is kx to the power of 4, 1/5 ab. Like that it will come. If it is kx, half ab. See here it is half ab. It is, the slope is kx. Slope is kx. It is half ab. Here k x square 1/3 ab. K x cubed 1/4 ab. So this all we get from understanding of integration and applying into the system. Now if you see here, in our other things, wherever we use this integration, integral v dq is the charge of by a battery. When we charge battery to voltage v, so this is v dq. V ds is the magnetic field. Integral v di is the power. Integral f ds is the work. Integral a dt is the velocity. Integral v dt is the displacement. Integral I square r dt is the energy consumed, heat energy. So like that, many places we use this integrations. So we have to be familiar to do how to do integration, so that all physics and other subjects are made easy. We can understand them better. Okay, let us go to the topic. So integration is nothing but a reverse process of differentiation. Differentiation is slope, integration is area. Differentiation is what? Dy by dx. Suppose if you see here, what is differentiation here? This is dy by dx. The slope is tan theta, that is m is equal to b by a. So here dy by dx of this line is b by a. But integration means this area. Differentiation means the slope. Here also. What is the differentiation? Kx square, 2kx, 2kx. So this is the slope. At here, 2. If suppose x is 1, 2k. If x is 2, it is 4k. Like that, the slope at that point is 2kx. But integration is area under the curve. These two are opposite terms. These two are opposite terms. So this is anti-differentiation, isn't it? That means if I put dy dx of integral fx is fx itself. Suppose if I differentiate dy dx of f of x, this dy dx and f integration get cancelled out. So integration of f dash x is equal to f of x dx. F of f dash x is f differentiation is f dash x, fx plus constant. So if I differentiate here, suppose right hand side I am differentiating, what I am getting? F dash x plus 0. So c can be anything. C can be anything. F dash x plus 0 will satisfy my left hand side. So that is why the constant appears in indefinite integrals. This is indefinite integrals. In definite integrals, it get cancelled from limits a to b. Suppose here the limit is 0 to a. Here c gets cancelled out. Plus c at 0 plus c at a also, though that get cancelled. But in indefinite integrals, we have to write plus c. In definite integrals like work done, area, what we have seen now, c gets cancelled out. But in indefinite integrals, we have to add c. This chapter is basically indefinite integrals. Let us see some standard forms. This we have already done in earlier. Now we are only understanding, revising rather. So we know. So what is x to the power of n plus 1? d by dx of x to the power of n plus 1 into x to the power of n. Now I am adding both sides integration. So integration of d by dx means integration get cancelled. So x to the power of n plus 1 is equal to n plus 1 integration of x to the power of n dx. This n plus 1 is a constant. I am taking the other side. So integral x to the power of n dx is equal to 1 by n plus 1 into x to the power of n plus 1. So I'm just rearranging the terms. Here what I'm doing, this dx I'm sending here. d by dx is going and integration. Integral of x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. So this is a rearrangement of terms. So we know log x is 1 by x. Integral log x is 1 by x. 1 by x dx. We know integral e to the power differentiation of e to the power of x ex. So integration also e to the power of x. So differentiation is 1 by x. So integral 1 by x is log x. Here you see log cannot be defined in negative. So that way always remember we put mod. This should be positive figure because log is not defined for negative figure. So integral 1 by x dx is log of mod x plus constant. Again e to the power of x plus c constant. What is integration of a to the power of x? So a to the power of x by log a plus constant. Let us see here. Let us see a to the power of x. A to the power of x, log of a to the power of x can be written as x log a. Log of a to the power of x, x comes to this side. So x log a. So that means a to the power of x is equal to, I am taking this e to the other side, e to the power of x log a. E to the power of x is equal to e to the power of x log a. Now d by dx of a to the power of x is equal to e to the power of x log a into differentiation of this is log a. So log a into e to the power of x log a. But e to the power of x log a, we know a to the power of x. E to the power of x log a is equal to a to the power of x. So log a into a to the power of x. So when I do differentiation on both sides, integration of a to the power of x is equal to e to the power of x by log a. E to the power of x by log a plus c is the integration of a to the power of x. Just we'll have again revise this. Log a to the power of x can be written as x log a. Then I'm bringing a to the, I'm opening log here. A to the power of x is equal to e to the power of x log a. So I'm differentiating a to the power of x, dy dx of a to the power of x is equal to e to the power of x differentiation, e to the power of x into dx. So e to the power of x log a into x log a differentiation is log a. So that means log a into a to the power of x. So when I integrate on both sides, the integration of a to the power of x is equal to a to the power of x by log a plus c. Log a means log a to base a. Okay. So this is how this formula has come into existence. Integration of e to the power of x is e to the power of x plus c. Integration of a to the power of x is a to the power of x by log a plus c. Okay, we'll go to other forms. Let us see sin x cos x forms. Before going to this sin x cos x forms, see, now we are learning dy dx of sin x cos x and other things. Before going through this, let us go to the basic understanding of sin x. How sin x is defined? The expansive term x minus x squared by 3 factorial plus x to the power by 5 factorial minus x to the power by 7 factorial, like that. This is a Euler's expanding formula. This is cos x is defined. This is e to the power of x is 1 plus x2 by 1 factorial, x squared by 2 factorial, x cubed by 3 factorial, like that e to the power of x is defined. Now you see here, suppose if I do differentiation of sin x, what will this x will become? 1. 3x cubed will become 3x square. So 3 and 3 get cancelled. So 2 factorial is left out. 1 minus x square by 2 factorial. This is 5x to the power of 4. So x to the power of 4, 5 get cancelled, 4 factorial. X to the power of 4 by 4 factorial. So like that, when I do differentiation of sin x, I am getting cos x. So differentiation of sin x is equal to cos x. Now I am doing differentiation of cos x. 1 will become 0. This is minus 2x. This is 2x. 2 into 2 get cancelled. X by 1. So minus x by 1. This is plus x. This is minus x by 1. Now the second term. This is 4x cubed. 4 get cancelled. X cubed by 3 factorial plus x cubed by 3 factorial. This is minus x cubed by 3 factorial. This is plus x cubed by 3 factorial. So if you see is total terms, this is up to infinity. So it starts from minus x plus x cubed by 3 factorial minus x to the 5 by 5 factorial plus x to the 7 by 7, like that. So that means dy dx of cos x is minus sin x. Minus sin. Similarly, e to the power of x. I am doing differentiation of e to the power of x. X to the power of 0, 1. 1 becomes 0. X to the power of 1, differentiation is 1 plus x square. 2x by 2 factorial. 2 get cancelled. X by 1 plus 3x square. So x square by 2 factorial. It's again repeating. X square by 2 factorial. X by 1 factorial. 1. So it's up to infinity series. So e to the power of x differentiation will result in e to the power of x itself. So by understand the basic Euler's expansion, if we understand, if we by heart, we can able to understand the difference. Rather, what we said, the slope of sin x is cos x. The slope of cos x is minus sin x. The slope of e to the power of x is e to the power of x itself. So in terms of dy dx means slope. Dy dx means slope. So the slope is cos x. The slope is minus sin x. Slope is e to the power of x. Or we can understand by the expansion differentiation, because infinity series they get repeated. Okay, now we'll understand the. So we know integration of sin x is minus cos x is sin x, secant square is tan x, all plus c. Indefinite integrals will have constant terms added. Cosecant square is minus cot x, secant x tan x is secant x, cosecant cot x is minus cosecant x. So these are the basic which we have learned in earlier classes. So integral cot x. Integral cot x can be written as cos x by sin x. So when we say log sin x differentiation is what? 1 by sin x differentiation is cos x. So cos x by sin x will become cot x. So this is log of mod sin x plus c, because sin x can have minus 1 to plus 1. But here minus 1 to 0 is not allowed here. It's only plus side. So log of plus sin x. So here it will give 0 to 90. x is between 0 to 90. It cannot be 0 to 180 also plus. Okay, x is between 0 to pi. So pi to 2 pi is not possible here. So log of mod sin x plus c. Similarly, tan x log of minus log of cos x plus c. Because log of when I differentiated 1 by cos x is minus sin x differentiate. So minus minus get cancel. Sin x by cos x is tan x. Differentiation of c is 0. So we get tan x. So understood. Now integral secant x. Integral secant x is log of secant x plus tan x plus c. This is very important formula. Many places we get this, and we have to use this also to simplify our integrations. You see here, log of secant x plus tan x plus c. So if I am differentiating is what I am getting 1 by secant x plus tan x. Top will get secant x differentiation secant x tan x differentiation secant square x. So out of it secant x will come out. So both numerator and numerator cancel. Secant x is left out. So integral secant x dx. Similarly comes for integral cosecant x. Integral cosecant x is log of cosecant x minus cot x plus c. Integral secant x can be written as in other form also. Here log of secant x plus tan x can be written as tan pi by 4 plus x by 2. This way also this can be represented in terms of half angle. X by 2 is the half angle. This is tan a plus b. Tan a plus tan b. So tan 45 is 1 plus tan x by 2 by 1 minus tan x by 2. Tan 45 is 1. So tan a plus tan b by 1 minus tan a tan b. And when we simplify this, we'll get secant x plus tan x. Similarly, cosecant x, integration cosecant x is log cosecant x minus cot x plus c. This can also be written as log of tan x by 2 simply. Cosecant x minus cot x is nothing but tan x by 2. So this is the up to this we have covered the formulas. Now these formulas, before going through these formulas, we will have a revision of this. Let us say what is sine inverse x by a. Let it be y. Sine inverse x by a be y. Then x by a is equal to sine y. So what is cos y? Suppose I am differentiating both sides. Cos y into dy is equal to dx by a. So what is dy by dx? Is equal to 1 by a cos y. So we know when sin y is x by a, cos y is 1 minus x square by a square under root. So dy by dx is equal to 1 by square root of a square minus x square. Here same I have submitted here. Dy by dx. What is y here? Y is sine inverse x by a. Y is sine inverse x by a. So differentiation of sine inverse x by a is equal to 1 by square root of this will become a square minus x square by a square. If it comes out of root, it will become a. This a and this a will get cancelled. C and a will get cancelled. So we are getting what we are left out is 1 by square root of a square minus x square. So if I do integration both sides, so sine inverse x by a is equal to integration of 1 by square root of a square minus x square. See here. One by a square integration of 1 by square root of, remember the square root is required here. Square root of a square minus x square is sine inverse x by a. So how we got this? Through this method. So I assume sine inverse, whatever right hand side we are getting, you assume them as y. In all the cases, assume them as y. So we will automatically get the, suppose let us say the secant inverse x by a. Let us say that secant inverse x is equal to y. So what is secant y is x? Secant has gone this side. Secant y is x. Now I am differentiating. Secant y tan y dy is equal to dx. So dy by dx is 1 by secant y tan y. So dy by dx is d secant inverse x. Dy is secant inverse x. D by dx of secant inverse x is equal to 1 by, what is tan y? Tan y is root of secant square minus 1, root of x square minus 1. What is secant y? Secant y, we know it is x. So 1 by root of x square minus 1. So integration of dx by x root of x square minus 1 is equal to secant inverse x plus constant. This is what is the formula. Integration of 1 by x root of x square minus a square is equal to 1 by a secant inverse x by a. Here a I am taking as 1. So secant inverse x plus c. In this example, we have taken a as 1. Otherwise, I have to put secant inverse x by a. Now similarly, see tan inverse x by a. Tan inverse x by a, let it be y. So tan y is equal to x by a. So secant square y dy is equal to dx by a. So dy by dx is equal to 1 by a into secant square y. So dy by dx, y we know, y is tan inverse x by a. This is y. So in place of y, I am putting, so in differentiation of tan inverse x by a is 1 by a into a square plus x square. There is no root here. There is no root here. Because it itself is secant square y. Secant square y is 1 by tan square. So 1 plus x square by a square. So a into a square plus x square. So integration of, so if you do integration both sides, integration of dx by a square plus x square is equal to tan inverse x by a. See here, integration of 1 by a square plus x square is equal to 1 by a tan inverse x by a. In these cases, 1 by a is not appearing because they are under the root. So a getting cancelled itself. Here there is no root, so this is 1 by a appearing. So 1 by a square plus x square is 1 by a tan inverse x by a. So you understood how this is moving? This is minus 1 by a square plus square, cot inverse x by a. Minus 1 by root of a square minus x square, cos inverse. Here plus 1, here minus 1. Because dy by dx of cos x is minus sin x. Sin x dy is cos x, but cos y dy is dx, cos y dy is minus sin x. So we will get minus sin here. So 1 by square root of a square minus x square is sin inverse x by a. Minus 1 by square root of a square minus x square is cos inverse x by a. 1 by root is removed. A square plus square is tan inverse x by a into 1 by a. Minus 1 by a square plus square 1 by a cot inverse x by a. 1 by a is on this side is equal to 1 by a cot inverse x by a. Now 1 by x root x square minus a square. Here you see the second term is x square in all. Now here the first term is x square. So 1 by x root x square minus a square, we have just seen 1 by a secant inverse x by a. This is what we have seen here. Secant inverse, secant y tan y. Secant y tan y is x root x square minus 1. Secant y is x, tan y is root of x square minus 1. So this is d by dx of secant inverse x. So integration of x root x dx by x root x square minus 1 is equal to secant inverse x. If a is added, 1 by a secant inverse x by a plus c. Similarly, cosecant, we'll put here minus 1. Minus 1 by x root x square minus a square is equal to cosecant inverse. Minus 1 by x root x square is equal to cosecant inverse 1 by a cosecant inverse x by a plus c. So, if you understand the basic of these 6 formulas, 1, 2, 3, 4, 5, 6, we will have to basically remember 3 formulas here, not 6. What are the 3? Sin inverse, tan inverse, and secant inverse. Cos inverse is minus of sin inverse. Cot inverse is minus, cosecant inverse is minus because it is minus 1, same. So integration of 1 by root of a square minus x square is equal to sin inverse x by a. Minus 1 is cos inverse under root. If root is not there, tan inverse will come into picture. If there's root is there because it is a sin theta. A square minus a square sin square theta. A will come out. So 1 minus sin square theta, that is cos theta. cos theta will come in the bottom. So like that. So here under root is coming means we have sine inverse and cos inverse. There is no root is 1 plus tan square x, 1 plus cot square x, like that. It is a 1 by a tan inverse x by a. So minus is cot inverse. Again, both are there. X root x square minus x square is x into tan. This is secant y, tan y. So x into x square minus a integral is equal to secant inverse x by a. Understood? Before we go to the next understanding of other integrations, we'll just remember here 1 by square root of a square minus x square is sine inverse x by a. Suppose in place of root of a square minus if it is a square plus x square. See, if root is not there, tan inverse x by a is coming to picture. But if root is there, root of a square plus x square, then this will become sine h inverse x by a. Hyperbolic function. Minus 1 by square root of a square plus x square is cos h inverse x by a. Similarly, in place of 1 by a square plus x square, if it is 1 by a square minus x square without root, a square plus square we know tan inverse. If it is a square minus x square, then tan h inverse. Minus 1 by a square minus x square, cot h inverse. So that we remember these four: sin h inverse, cos h inverse, tan h inverse, cot h inverse. Simply by changing the sign, we are getting them. A square plus x square sin h inverse, minus 1 by a square plus x square cos h inverse, a square minus x square tan h inverse, is minus 1 by a square plus a square minus x square cot h inverse. Simply by changing this, we are getting the hyperbolic function. That we'll review later, but to have a shortcut understanding and just correlating here itself. What is the difference between sine inverse x by a and integration? What is the difference between sine h inverse x by a and integration? Sine inverse is 1 by square root of a square minus x square. Sine h inverse is 1 by square root of a square plus x square. Okay, we'll go further. Just let's not confuse with them, but keep a background understanding. When we come to that subject, we will deal it. So this we have already seen. Sin inverse x by a, we got it 1 by square root of a square minus x square integration, and tan inverse 1 by a square plus x square, we got this, and secant inverse 1 by x root x square minus 1. These two we have proved. Now let us see here. Let us see here 4 curves. This is y is root x plus 2. Y is root x plus 2. When x is 0, y is 2. This is 2 point. This is when x is 0, y is 1. Then when x is 0, y is minus 1. So these are the 4 curves. Y is root x. When x is 0, y is 0. You see 4 curves are there. This is almost like a curve. So suppose if I am doing differentiation of this, integration of this, integration of 1 by 2 root x dx is equal to root x plus c. Integration of 1 by 2 root x dx is equal to root x differentiation is 1 by 2 root x. So I given 1 by 2 root x directly. So root x plus c. This c is nothing but minus 1, 0, plus 1, plus 2. For all these c, this integration is valid. Integration 1 by 2 root x dx is root x is valid. Root x is valid. So that is why the c is we are putting in the plus c. For any c, the slope is same. So this what is given? Half root x dx means what? This is the slope. The equation of this line is half root x dx. So half root x. So when I integrate this, I am getting the actual curve. At this point, this is the curve. So that is the importance of plus constant. So let us understand this. Dx by x square minus a square. These are all first a square, then x square. Now we are going to other side, x square minus first a square is coming here. Dx square root of x square minus a square is equal to log of x plus square root of x square minus a square plus c 1 by a into log of x plus square root of this by a. X plus square root of x square minus a square by a plus c. Similarly, dx by x square minus a square is equal to 1 by 2a log of mod of x minus a by x plus a plus c. Let us understand these two. First this one. 1 by x square minus a square. 1 by x square minus a square can be written as x plus a into x minus a. So when I do partial fractions, I am getting 1 by x minus a minus 1 by x plus a. When I do LCM, this becomes x minus a into x minus a, x square minus a square. So x minus a, x plus a minus x plus a. So it becomes 2a. Becomes 2a by 2a. I'm putting by 2a. So 2a getting cancelled. In the numerator, I'll get 1. So when I do partial fraction, this is log x minus a minus of log x plus a. So this is log of x minus a by x plus a. So 1 by 2a is a constant figure. So when I do integration of dx by x square minus a square, this is no formula. Nothing is to be remembered here. Simply you do fraction a square minus b square and you do partial fractions log x minus a by x plus a 1 by 2a plus c is the integration of the. Now this one, integration of x square minus a square. Log of x plus square root of x square minus a square plus c. Here, two ways of doing this. Use x is equal to a secant theta. X is equal to a secant theta. Then what I am getting is secant square, a square secant square theta. A will come out. Secant square theta minus 1. Secant square is a tan square theta. So 1 by tan theta will come. So dx by tan theta. Tan theta when it goes up, what it becomes? Tan theta dx by tan theta. It goes up cot theta. Cot theta. So let us understand how this formula has come into picture. Dx by square root of x square minus a square. See, this is not with any standard format. If you see all this is not a square minus, this is a square minus x square. This is not x square minus a square. This is also a square minus x square. A square plus x square, root is not there. So slightly tallying with this, but x is there. So this is slightly different. Integral dx by square root of x square minus a square. So this is answer is log of x plus square root of x square minus a square plus c. Let us see how it has come. Let us say I am differentiating log of x plus square root of x square minus a square. So log of differentiation is 1 by x into dx. So 1 by x into differentiation of this is 1 plus 1 by 2 root x into 2x. 1 plus 1 by 2 root x into x square differentiation is 2x. So if I do the LCM, what I am finding it, 2 getting cancelled, 2 getting, this becomes x by root of x square minus a square. So here when you do LCM, bottom x square minus a square will be there, root of, here we'll get root of x square minus a square plus x. So x plus square root of x square minus a square by root of x square minus a square, this portion is big. So these two, this is denominator, this is numerator, these two get cancelled. So what is left out? Dx by square root of x square minus a square. So this is one way of representing log of x plus square root of x square minus a square is integration of dx by f root of x square minus a square. Here you see, we know, let me go back. Now we know that sin squared theta plus cos squared theta is 1. So if I put here x is a sin theta or a cos theta, I am getting a square minus a square sin square theta. So 1 minus sin square theta cos theta I am getting. But in x square minus a square, here, because we have one rule here, cos h square theta minus sin h square theta is what? Hyperbolic function. So we put this as a cos h theta. So a coming out of cos h square theta minus 1. That is sin h square theta. So it becomes sin h theta. Because here cos square theta minus 1 sin h square theta is 1. So 1 coming this side, sin h square theta going the other side, you get a under root a positive term of sin h square theta. So sin h theta. Same thing is used here. If you see here, let x is equal to a cos h theta. So root of x square minus a square becoming sin h theta. I'm taking out a outside, so a sin h theta. So what is dx? Dx is equal to a sin h theta d theta. Because cos h theta dx is also sin h theta. So when I substitute integral dx by x square minus x square, I am getting simply theta. So integral d theta, because sin theta getting cancelled. So I am getting d theta is theta plus c. Theta is nothing but cos h inverse x plus c. Cos h inverse x plus c. So both are same answers. Either you put log of x plus square root of square minus a square, or put cos h inverse x plus c. See here, dx by square root of x square minus 1. So log of x plus square root of x square minus 1 plus c, or cos h inverse x plus c for x greater than 1 to infinity, minus cos h inverse minus x plus c for x less than 1 up to minus infinity. This is the ranges are given, but generalized formula is cos h inverse x plus c. Both are okay. Both are okay. So now we understood how these two have arrived at. Dx by x square minus a square, 1 by 2a log x minus a by x plus a. Similarly, a square minus x square. This is the same thing. A square, there is no root. So a plus x into a minus x. You do partial fractions. So 1 by 2a into log a plus x by a minus x. Same method we can use for both. This is the method. This is the method for both the cases. So this is simple method. 1 by a square plus a square, x square minus a square minus x square. This is not a square plus x square. See, a square plus x square. Here we cannot write it as a plus x into a minus x. Here we cannot write it as a plus x into a minus x. So here tan inverse x by a is coming to picture. But if it is a square minus x square or x square minus a square without root, then I can split it x plus a into x minus a and write in terms of partial fractions, converting into two partial fractions and converting to logarithm. Okay, but if it is root of x square minus a square, these are cos h inverse. As I told you earlier, a square minus x square. If it is minus 1 by a square plus x square also, or 1 by root of x square minus a square, dx by root of x square minus a square also is cos h inverse. Here a square plus x square, sin h inverse. Here a square minus x square, we have simply log of tan x plus a by x minus a, or tan h inverse also will come into picture. So let us revise these again. Dx by square root of x square minus a square is equal to log x plus square root of x square minus a square by a plus c, or cos h inverse x by a. Now here dx by cos h inverse x by a, because theta is x by a is there, x by a cos h inverse x by a. Because this is a comes this way, theta is cos h inverse x by a. Okay. So we got is log of x plus square root of x square minus x square, dx by square root of x square minus x square. Now these two we have already did. So directly square root of x square minus a square. Directly square root of x square minus a square. Here this is also square root of x square plus a square. This is also square root of a square plus a square in the numerator. They are not in the denominator. They are in the numerator. You see, square root of these are all denominators. So the same thing is given in numerator. Root of x square plus square. Now here I am using UV formula. Here I am using UV formula. So x square minus the same I am using. Same I am using, and here it is x. X is the integration of 1 is x minus a square by 2. We know this differentiation is integration of 1 by 2 root x square minus a square. we have just seen dx by square root of x square minus a square is log of x plus square root of x square minus a square plus c. So this is the formula we get by using UV formula and using this formula. Same here also, UV formula and log of x square plus a square, 2x plus square root of x square plus a square, root of x square plus a square, root of x square minus a square. See here, root of a square plus x square or x square plus a square. Either it is sin h inverse or log of x plus square root of x square plus a square by a to c. A square minus x square, same thing. 1 I have put here and so this we need not as such by heart. We have to do by putting 1 and UV formula. Subsequently, we will learning this UV formula. Put U as 1 and we can derive this from the existing formulas. This becomes 1 by 2 root x square minus a square. So 1 by 2 root x square minus a square will automatically get me the formula. Let us see one we will derive. Integration root of x square minus a square dx. Okay, I'm just showing here the derivation. Integration of root of x square minus a square dx. So I'm putting 1 into root of x square minus a square dx. So I'm putting 1, integration of 1 is x. So x root of x square minus a square minus integration of x into the second one is differentiation. 1 by 2 root x square minus a square into 2x dx. So what is giving x root x square minus a square minus integration of x square by root of x square minus a square dx. So again, x root x square minus a square minus integration of, I am putting x square into two terms, x square minus a square plus a square. So a square square cancel, x square remains. So what is this begin? X square minus a square dx. Root get cancelled. So top root will be remaining minus a square into dx by root of x square minus a square. So this we have know this formula. This formula is integration dx by square root of x square minus a square. This is what just we have learned here. Dx by square root of log of x plus square root of x square minus a square by a. So this one is becoming a square into log of x plus square root of x square minus a square. Now what is this one is becoming? Integration root of x square minus a square dx is same as this. This is it. Integral root of x square minus a square dx. This is also root of x square minus a square dx. I am sending it to the left hand side. So it becomes 2 root of x square minus a square dx integral. So 2 will come to the other side. So 2 root of integral x square minus a square dx is equal to x root of x square minus a square minus a square into log x plus root of x square minus a square plus c. Because this is the same term what we are integrating. So this minus will go to other side. So finally the 2 will come here. So x by 2 square root of x square minus a square minus half into a square log x plus x square minus a square plus c. This is what is the derivation of this setup. This is the setup. Integral root of x square minus a square equal to x by 2 square root of x square minus a square minus a square by 2 log of x plus square root of x square minus a square plus c. Similarly, same way can be derived. Here in place of x square minus a square, it is x square plus a square. Similarly, x by 2 square root of x square plus a square plus a square, here minus, it is plus. By 2 log of x plus this is minus, this is x square plus a square plus c. Similarly, a square minus x square. A square minus x square, same way we can prove that here in place of log, I am getting sine inverse x by a. Getting sine inverse x by a. So x by 2 square root of a square minus x square plus a square by 2 into sine inverse x by a. So we need not by heart these three formulas. Not by heart, but we have to by heart this formula. This is either we have to write it as cos h inverse x by a or write it as this. So this also we have to by heart, but we can at the time x minus a and x plus a and partial fractions and log of x minus a plus or minus log of x plus a, log of x minus a by x plus a, logarithmic property, we have to use it. Better to by heart this. These are the basic by heart. This is a derivative by heart. Okay. Can you go to the next one? See, whatever we have read, I'm just putting here. Dx by square root of 1 minus square is nothing but sine inverse x. Dx by square 1 root of 1 plus x square sine h inverse x. See, root is there. Root is not there, tan inverse. Root is there, in place of 1 minus square, it is 1 plus x square sine h inverse x. Or we can term it as log x plus square root of 1 plus x square plus c. Root of a square plus x square. It is nothing but dx by root of a square plus x square. Here a is 1. A is 1. See. This is dx by square root of a square plus x square. Here is here. See here, integration of square root of x square plus x square dx is equal to, this is the formula. X square to log x plus root of x square plus a square is the formula. So here, this is integral dx by square root of 1 minus x square is simply sine inverse x plus c. Or if it is minus dx by square root of 1 minus square is cos inverse x by c, or we can write it as minus cos inverse x plus c. Similarly, dx by square root of x square plus 1 or dx by square root of x square minus 1. You see these two terms, dx by square root of x square plus 1, dx by square root of x square minus 1. This can be written as log of x plus square root of x square plus 1 plus c, or log of x plus square root of x square minus 1 plus c. So when I differentiate, I am getting same answer. See here, log of x plus square root of x square minus a square. In place of a square, it is 1. In place of a square, it is 1. A is 1 here. So when I am differentiating, I am dx by square root of x square minus 1. So dx by square root of x square minus 1 is log x plus square root of x square minus 1 plus c, or dx by square root of x square plus 1 log x plus square root of, because root of x square minus 1 or x square plus 1 is not tallying with any standard formula. X square plus 1 is root, so this is not root. X square minus 1, not, this is all root, but this is a square minus a square, it is not x square minus a square. So it is not tallying with the fundamental first 6 formulas. So in that case, we use root of x dx by square root of x square plus 1 or dx by square root of x square minus 1. Otherwise, if you see from the shortcut, x square plus a square, x square plus 1, we told us sine h inverse x. Same thing is earlier. See, dx root of x square plus 1 sine h inverse x, or log x plus 1. Root of x square minus 1 cos h inverse x. Cos h inverse x. So these two, let us by heart. So others, this we know, minus dx by this we know, minus cos x. Minus dx by square root of x square plus 1 is again cos h inverse. Because simply reverse, sign is changing here. Here it is minus, it is plus. Cos h. Similarly, this is tan, 1 by 1 plus x square is tan x inverse, 1 by 1 minus x square without root, dx by 1 minus x square. So if it is 1 plus x square, I know it is tan inverse. Since it is 1 minus x square, it is tan h inverse x. Or we can write it as, we know this a square minus x square, log 1 plus x by 1 minus x. This is the formula. So with the fundamentals, by changing the signatures, we get h inverse, or we get log x plus square root of x square minus a square, or x minus square root of x square minus a square. So these two. So this, let us not by heart this. This we have to do UV formula because root is in the numerator. This root is the numerator. This is the numerator. This is denominator. We know this formula. But you do numerator, you do UV formula and do. It's not by heart. But this portion has to be by heart. Of x square plus 1. Either it is sin h inverse x, or wherever sin h inverse is coming, we know log x plus square root of x square plus 1. Where cos h inverse is coming, log x plus square root of x square minus 1. Just remember this. Okay. Tan h is coming. This is simple log 1 plus x by 1 minus. So we just revise these secondary formulas. These are all primary plus some part of secondary. These formulas we have just revised. This is a proof we have already seen just now. Integral root of x square minus a square is a UV formula, and we have derived this formula. This formula has been x by 2 square root of x square minus a square by 2 log x plus square root of. This is the derivation. You can pause and see again revision. So what are the properties? So integration and differentiation, they get cancelled out. Fx will be remaining. K will be coming out. K integral fx dx. If there are different fx dx, I can do independently. All the fx dx can be done independently. And we have f dash gx and g dash x is in f of x. Suppose if I am doing differentiation of this, what I am getting? F dash gx into g dash x. C will become 0. So f dash x into g dash x. This is f dash x, f dash gx into g dash x. So this is a reverse process of this. We will use in the problems solving. Before going to the problem solving, let us understand some trigonometric hyperbolic functions. Trigonometric hyperbolic functions. Hyperbolic functions are analogous of trigonometric functions. In trigonometric functions, they are in circle. Trigonometric functions are defined in circle. Suppose circle is there, or sine theta, or cos theta. This is a circle-based trigonometric functions. But hyperbolic functions are not circle. They are hyperbola. See, this is an hyperbolic function. This is an hyperbolic function. This is sin hx. Sin hx. This is cos hx. This is tan hx. This is tan hx, cot, secant, and cosecant. So this is cot hx, secant hx, and cosecant hx. These are not formed on circle. Trigonometric functions are based on circle, but these hyperbolic functions are based on hyperbolas. So sin hx looks like this: cos hx, tan hx, cot hx, secant hx. If you see their definition in the expansive form, so this is sin hx. E plus x minus e to the power minus x by 2. Suppose I am doing differentiation of sin hx. What I will get? E to the power of x plus e to the power of minus x by 2. Because minus into minus plus. So this is nothing but cos hx. When I do differentiation of cos hx, e to the power of x minus e to the power minus x by 2. Because minus will be coming here. So this is sin hx. This is not minus sin hx. This is sin hx. So now what is cos squared hx minus sin squared hx? This will become 1. Cos squared hx minus sin squared hx is equal to, when you do this part, this will become 1. Cos squared hx minus sin squared is 1. Secant square hx plus tan h square x is 1. Cot square x plus cosecant minus square is 1. If you do these minuses, we will get the answer. So cos h square x minus sin square x is 1. If we add this, suppose cos square x plus sin square x is 1. But in hyperbolics, cos h square x minus sin h square x is 1. Because this is a fundamental definition. This is how these curves are defined. So secant h square x minus secant square x minus tan square x is 1. But here secant h square x plus tan square is 1. Again, cosecant square x minus cot square x is 1. Here it becomes cosecant h square x minus cot square x is minus 1. So there is a slight difference between a trigonometric curves and a hyperbolic curves. Basically, hyperbola means what? What is sin hx? Sin ix Sine x is not sine x, it is sine ix. Is a y coordinate. X is x coordinate, ix becomes y coordinate. Is a pi by 2 degree phase difference in ix. So sine ix is equal to I sine of hx. Cos ix is equal to cos hx. Here I is not coming. In the cos sector, 90 is positive on both sides. Suppose cos theta is positive here, cos is also positive here. So I is not appearing in cos, but sine it is appearing. Tan will come I tan hx. Secant ix is equal to secant hx. So cosecant ix is equal to minus I cosecant x. Cot ix is minus. Because wherever the combination is coming, we are getting I. Wherever it is only cos and secant, I is not there. So similarly, sin h ix is equal to I sin x. Cos h ix is equal to cos x. Tan h ix is equal to I tan x. So from hyperbolic to normal, normal hyperbolic to normal. So it is only to have an understanding of hyperbolic functions. Because in our derivations, we are getting sin h inverse x. See, this is cos h inverse x. This is sin h inverse x. Somewhere we get sin h inverse x. Root of 1 plus x square is sin h inverse x. Root of x square minus 1 is cos h inverse x. Under root. So to understand the hyperbolic functions. Okay. So some. Okay, now let us understand this. So integral sin hx is cos hx plus c. Integral cos hx is not minus sin hx, it is directly sin hx. Because we have seen derivations are same. When I derivate cos hx, I am getting sin hx. When I derivate sin hx, I am getting cos hx. So secant square hx is tan x plus c. Cosecant square hx is minus cot hx plus c. Secant x integration of secant x derivation is secant hx tan x. It's minus. This is minus cosecant hx plus c. Integration of cosecant hx cot x dx is equal to minus cosecant hx plus c. So these are the hyperbolic expand integrations. Now we have seen here integral dx by 1 plus x square. Earlier we know 1 minus x square is sin inverse, 1 plus x square is sin h inverse x plus c. Or whenever h is there, I can put log of x plus square root of 1 plus x square. Similarly, dx by x square minus 1 is cos h inverse x. Is cos h inverse x plus c, or we can write this as log of x plus square root of x square minus 1 plus c. If it is 1 to infinity, it is minus 1 to minus infinity, minus of log of minus x plus square root of x square minus 1 plus c. If it is between minus 1 to plus 1, log of x plus square root of x square minus 1 plus c. Same. So for three ranges, three formulas are given. This is cos h inverse x, this is minus cos h inverse x. So this is based on hyperbolic section, where we'll be using in solving the problems. So differentiation of tan x is secant square x. Differentiation of minus cot hx is cosecant square x. Differentiation of secant hx is secant hx tan hx minus secant hx. Differentiation of minus cosecant hx is cosecant hx cot hx. Slight difference between trigonometric and hyperbolic. So this difference we are using in this formula. Here what we say? Cos h square x minus sin square x is 1. But there cos square theta plus sin square theta is 1. So depending on this, I am using in these formulas. So it is minus root of minus means I can use cos. Here it is minus, I can use cos. Here it is a square minus x square. So 1 minus sin square theta, cos square theta. If it is x square minus a square, I have to use cos h. So depending on a square plus x square, I can use 1 plus sin h square theta is cos h square theta. 1 plus sin h square theta is cos h square. Like that I can use because of this difference of the property. To convert the root into a simple non-rational number. So let us see this. Suppose sin square x, we know we can write in terms of cos 2x is 1 minus 2 sin square x. Cos 2x is 1 minus 2 sin squared x. So we make sin squared as a subject. What is it? Cos 2x is 2 cos squared x minus 1. We make cos squared x as subject. Sin x is 2 sin x cos x. So sin 3x is 3 sin x minus 4 sin cubed x. Here we are making sin cubed as my subject. So 3 sin x minus 4 sin cubed x. So here cos 3x is 4 cos cubed x minus 3 cos x. So I have to make these things as subject. So I can convert them into a linear expansion where I can integrate. I know cos nx I can integrate. Cos nx when I integrate sin nx by n. Cos 3nx I can integrate sin 3nx by 3n. But cos cubed nx can I integrate? No. I need support. Cos cubed either it should be cos to the power 4nx by 4 into sin nx. There is no sin nx here. Cos to the power 4nx by 4 into sin nx should be there. It is not there. So it cannot be. Okay? So it has to be converted into linear functions. Similarly, tan square x is secant square x minus 1. Cot square is cosecant square x minus 1. We know this. We know the splitting of functions. I cannot integrate sin a sin b. Can I integrate? If it is sin square a, I can integrate. So it can be sin cubed a by 3. So 3 sin square a into cos a. But it is cos b. It is not even cos a. So sin a cos b. So you know sin a plus sin b, sin a minus sin b, cos a plus cos b, cos a minus cos b. We know sin a cos b plus cos a sin b, cos a cos b minus sin a sin b. So sin a cos b is the first term. In sin a cos b plus cos a sin b, cos a cos b minus sin a sin b. So sin a cos b is the first term. So sin a cos b is equal to sin a plus sin b. Sin a plus b plus sin a minus b. Cos a sin b is second term, sin a plus b minus sin a minus b. Cos a cos b is the third term, cos a plus b minus cos a minus b. Minus 2 sin a sin b is the fourth term, cos a plus b minus cos a minus b. So this comes in the, so minus is removed here, put here. So this is my standard trigonometric expansions. So if it is here, I cannot integrate. In this form, I can easily integrate. So we have to convert them into a integrable form. So how we'll write this? Sin a plus b plus sin a. Suppose 2 is not there. Here automatically 2 will come here. 1 by 2 sin of a plus b plus cos of plus sin of a minus b. Here half into sin of a plus b minus sin of a minus b. Here half into cos of a plus b plus cos of a minus b. Here half into cos of a minus b minus cos of a minus b. So we should have very strong knowledge of these expansions. Now you know this is a partial fraction. I am converting px by qx into different partial fractions. That's how we have done here partial fractions. See, 1 by x square plus x a square. This is x plus a and x minus a. I convert into 2 partial fractions. So this is my easy, my log of x minus a minus log of x plus a. So wherever I could convert them into partial fractions, again I should be able to do it so that I can convert this into an integrable form. So some standard formula, you know, if tan x by 2 is t, sin theta is 2 tan theta by 1 plus tan square theta by 2. 2 tan theta by 2 by 1 plus tan square theta by 2. So tan theta by 2, if I take it as t, this is sin cos x is equal to 1 minus tan square theta by 2 by 1 plus tan square theta by 2. Similarly, so we can use these conversions for making the problem into integrable one. Suppose here it, you know, tan x by 2 is this. So when I do, what is x here? Tan inverse t, 2 tan inverse t. So dx is equal to 2 into dt by 1 plus t square. Tan inverse t, what is differentiation? 1 plus t square. So we can use this in place of dx, I put 2 dt by 1 plus t square. In place of other x by 2, I put the corresponding all terms, tan, sin, cos, all are converting into t. So it is easy for me to solve my integrations. Okay. Hello students, let us continue integration. First we will do solved problems of the exercise. Before that the examples, some good examples are there that we will review, then we will take up the exercise. Okay. So let us see from examples. Integration of x to the power of 6 minus 1 dx divided by x square plus 1. So what is given is x to the power of 6 minus 1 by x square plus 1. We will do simply divide these two. How to approach this? Is this any dx of this? No. Is this any power of this? No. So we are going to divide this. So when I am dividing x to the power of 6 minus 1, first I will multiply x to the power of 4. So it means x to the power of 6 plus x to the power of 4. So minus x to 1 minus x to the power of 4 minus 1. Then I am multiplying with minus x square. So finally what I am getting, this is the quotient and this is the remainder. So what I am getting, x to the power of 4 minus x square plus 1 minus 2 by 1 plus x square. You know, this we can do x to the power of 5 by 5, x to the power of cubed by 1 plus x. This is 2 tan inverse x. So we got the answer plus constant. See here. So why you have to divide? I want in a integrable form. This two quadratic equations division. I want in a. I know 1 plus x square is tan inverse x. So I have to bring it to a x level. Even if I bring it to an x level also, it will be over. But this is getting x is not there in the term. So we are getting next. So let us see another one. Sin x plus cos x positive. See, when we say sin x plus cos x is positive, here cos is positive, cos 45. Here cos 45 is negative, sin 45 is positive, so here it is 0. Here cos 45 positive, sin 45 negative, 0. This whole zone is sin x plus cos x is positive. This zone is negative. This zone is negative. So the next problem, we'll see that why this has come here. So this is positive zone of sin x plus cos 2. Only sin x positive, 0 to pi. Only cos x positive, minus pi by 2 to plus pi by 2. But when you superimpose these two, this is the one which is positive, other side is negative. Will come in the next problem. So now we'll see exercise 6.A1, some special problems for building up the knowledge. Integral 2x square cubed root of 2x square dx. Simple. X to the power of 2 by 3 plus 1 by 2 by 3 plus 1. X to the power of 2 by 3 plus 1 by 2 by 3 plus 1. So 2 to the power of 1 by 3 into x to the power of 5 by 3 by 5 by 3. 5 by 3 means 3 by 5 plus constant. Similarly, 1 minus root x by x dx. So I am converting it to two separate numbers. 1 by x dx minus root x dx. So 1 by root x dx. 1 by x is log x. 1 by root x is 2 root x. So log x minus 2 root x plus c. Similarly, this one, e to the power of x minus 1 by x plus 2 by root of x square minus 1 dx. So e to the power of x integration is e to the power of x. 1 by x integration is log x. 2 by root of x square minus 1, we have just seen log of x plus square root of x square minus 1. Or we can write this as cos h inverse x also, but presently we are using 2 into log of x plus square root of x square minus 1 as c. We have to get acquaintance with the formula of 1 by square root of x square minus 1. Once we solve the problems, we will be getting. So if it is 1 by square root of x square minus 1. If it is x square plus 1, log x plus square root of x square plus 1. Now, integral 1 by 1 plus x square, simply tan inverse x. 1 by 1 minus x square, this is sin inverse x. So tan inverse x plus 1 minus root, it's not root. If it is root, it is sin inverse x. Since it is not root, it is tan h inverse x. We have seen here 1 plus x square is tan inverse x. 1 minus x square without root. It appears to be tan inverse with a sign different. So we call it as tan h inverse x. Or we can write this as log 1 plus x by 1 minus x. This we have seen. Half log, this is 1 minus x square can be written as 1 plus x square into 1 minus x. 1 plus x into 1 minus x. We do partial divisions, we'll get log 1 plus x by 1 minus x. We can write like this, or we can write tan h inverse x. Both are okay. So, but we know 1 by 1 minus x square dx is log 1 plus x by 1 minus x. See, we have seen here this formula. This formula 1 by a square minus x square, 1 by 2a log a plus x by a minus x. 1 by a square minus x square. There is no root. Okay. Now 1 by square root of 1 minus x square. This is straight away sin inverse x. 1 by square root of 1 plus x square. This is sin h inverse x. So sin inverse x plus sin h inverse x. Or we can write 1 by square root of 1 plus x square as log of x plus square root of 1 plus x square plus c. Okay. Sin h inverse in this form. Cos h inverse in this form. Okay, now we go. E to the power of log of 1 plus tan square x. Integration of e to the power of log of 1 plus tan square x. This is totally is under e to the power of x. So let e to the power of log x is y. Let e to the power of log x is y. That means what? Log x comes to here. Log x. Both sides I am taking log. Log e to the power of log x is log y. So log x is coming into multiplication. Log x into 1 is equal to log y. So log x is equal to y. Log y. That means x is equal to y. In the same way, e to the power of log 1 plus tan square x is nothing but 1 plus tan square x. Because this is log. We have seen this. E to the power of log x is x itself. E to the power of log x is x itself, because its total is y is equal to x. So same way, e to the power of log 1 plus tan square x will become log 1 plus tan square x. This we know. 1 is x, tan square x is 1 plus tan square is secant square x. So takes integral secant square x is tan x plus c. So here we should have a knowledge of e to the power of log x and also other trigonometric knowledge. Now let us say integration sin square x by 1 plus cos 2x. Sin square x by 1 plus cos 2x. So 1 plus cos 2x can be written as 2 cos squared x minus cos 2x is 2 cos squared x minus 1. These two get cancelled. So 2 cos squared x. So sin square x by 2 cos square x. That is integral tan square x. Tan square x can be written as secant square x minus 1. So this is tan x minus x plus c. See how the flow is going on. We have to simplify the equation. Here 2 cos squared x minus 1. So it will become 1 by 2 tan square x. 2 will be there. So 1 by 2, here comes 1 by 2 tan square x. So here it comes, so 1 by 2. Because 2 is there. This 2 we have not taken into consideration. This is also 1 by 2. This is so we got to, if it is 2 sin square 2x, then 1 by 2 will not be there. If it is 2 sin square 2x, this 2 get cancelled, then will be tan x minus x plus c. So this 2 is there. Okay, we go to next one. See again, where this section 1 is over. Section 1 we have taken typical problems of first 6A 1. Now 6A 2 we are going to some specific problems. Problem number 5. Integration of 2x minus 1 whole square by 9x dx. This I am separating. because I want it to be in the form of x. So this I am expanding and putting 9x in the bottom. So when I am dividing, I am getting this is x. 4 by 9, 2 is there. 4x square by 9x. 4 by 9. This is x. X becomes integral x is x square by 2. So 2 by 9 it's coming. Here x dx becomes 1 by 9. 1 by 9 into log x is 4x. 4 by 9 x plus c. So we have expanded and simplified the process. Division of x is divided. Like we have done division in the quadratic equation also, we have done here division. This we have done division. Say here also it is simple division. Now let us see this. Integral of 1 by root x plus 2 by root of x square minus 1 minus 3 by 2 x square dx. This is a 3 form. 1 by root x integration is 2 root x. 2 by root of x square minus 1 is 2 log x plus root of x square minus 1, or we can say cos h inverse x. But let us put 2 log x plus square root of x square minus 1 minus 3 by 2 x square means plus 3 by 2 x. See, if I differentiate this 1 by x, how much I am getting? X to the power of minus 1. So minus 1 into x to the power of minus 2. So minus 1 by x square. So minus 1 by x square, when integrate, it will become plus 1 by x. So 3 by 2 x plus c. See, this is cos h inverse x. So let us familiar with both answers. 2 log x plus square root of x square minus 1 plus or cos h inverse x. Let us see another one. Integration of root x minus 2 by 1 minus x square dx. Simple. Root x we know. X to the power of 1. X to the power of half means x to the power of 3 by 2 by 3 by 2. This integration. So 2 by 1 minus x square. There is no root here. If it is 1 plus x square, it is tan inverse. Since it is 1 minus x square, it's tan h inverse x. Or we can log it as 1 plus x into 1 minus x and 2 by 2 log 1 plus x by 1 minus x. Or both answers are okay. So why x square minus 1? 1 minus x square written as 1 plus x into 1 minus x. So we have partial fractions and log 1 plus x by 1 minus x. Now another problem. Sin hx plus 1 by square root of x square plus 1 dx. Sin hx integration is cos hx. 1 by square root of x square minus 1. Either cos h inverse we can write, or we can write log x plus square root of x square minus 1 plus c. Now another one. 13. Integral a to the power of x minus b to the power of x whole square by a to the power of x b to the power of x dx. So here I am expanding this. A to the power of x plus b to the power of 2x minus 2 into a to the power of x bx by a to the power of x bz cancel minus 2 dx. So this become 2x. This is b to the power of 2x by a to the power of x b to the power of x. So it becomes b to the power of x by a to the power of x b by a whole to the power of x dx. Here a by b whole to the power of x dx. We have just seen a to the power of x log x. So this is called a to the power of b by x by log a by b, b to the power of a to the power of x by log b by a minus 2x plus c. So if I take 1 by log a by b, log a minus log b into a by. Divided by log a by b can be written as log b by a. That means log b minus log a. Divided by log b by a can be written as log a by b. Log a minus log b. So when I take out log a minus log b, here minus will come. So this y by a to the power of x, a by b to the power of x minus 2x plus. This is the simplified answer. So how we have proceeded here? We have simply expanded it, divided it, and made integrable form. So a to the power of x dx, we know the formula. Integral a to the power of x dx. Where is this integral a to the power of x dx? See, integral e to the power of x is e to the power of x. Integral a to the power of x dx is a to the power of x by log a to base a. This is the formula. So let us see. The same way we can do in a different form also. Let a by b whole to the power of x. A to the power of x, b to the power of x. Here we are getting a by b whole to the power of x, b by a whole to the power of x minus 2. Let a by b whole to the power of x is equal to y. Then what I call a log a by b whole to the power of x is log y. So x log a by b is log y. So when I say dx is equal to 1 by y dy into 1 by log a by b. So when I substitute integration of a by b to the power of x dx is equal to integration of y into 1 by y dy by log a by b. So y getting cancelled. So y by log a by b. What is y? Y is equal to log a by b whole to the power of x by log a minus log b. So this is same as this. So here we have done as per the formula. This formula is explained here. So let us see another problem. Integration of secant square x cosecant square x dx. Secant square x cosecant. If it is cosecant secant x, we know cosecant x is the answer, but squares are given. So let us understand. So cosecant square is 1 by sin square x. Secant square is 1 by cos square x. 1 by sin square x, 1 by cos square x. So 1 can be written as sin square x plus cos square x. So this total is converted to secant square x. This is cosecant square x plus secant square x. This is minus cot x. This is tan x plus c. Here plus c will come. So we'll do. Let us do other. Integration of secant square x cosecant square x can be written as 1 by sin square x cos x. This is 2 sin x cos x whole square is sin 2x whole. Sin square 2x. Sin square 2x. 4 by sin square 2x. So 4 sin square 2x comes upwards. This is cosecant square 2x. Cosecant square 2x means minus cot 2x by 2. So minus 2 cot 2x also is okay. So two methods. One is by simplifying as per given test simplified method, and we can use 2 sin x cos x as sin 2x. Now let us see. Integration of 1 plus cos square x divided by 1 minus cos 2x. See, 1 minus cos 2x can be written as 1 minus 2 sin square x. 1 getting cancelled, 2 sin square x alone. 1 plus cos square x by 2 sin square x. When you divide it, half cosecant square x plus half cot square x. Half cot square x. So cot square x can be written as cosecant square x minus 1. So this is half plus half become 1. So cosecant square become cot x and 1 becomes x by 2. So this is the answer. Integration of 1 by cos hx plus sin hx. So I multiply by cos hx minus sin hx. So cos squared hx minus sin squared hx is 1. This is 1. So this is sin h cos hx integrated sin hx minus cos hx plus c. Sin hx minus cos hx plus c. See, the integration of cos hx is sin hx. Integration of sin hx is cos hx. There is no minus here. No, because the integration of sin theta is minus cos theta, but sin hx is cos hx. We have seen earlier. This cos squared hx minus sin squared hx is 1. So we'll go to next one. Now, in the next things, we need to do substitution methods. We should do substitute. Here we have done the substitution method. Let a by b to the power of x is by here one substitution. And there is not much substitution has come here, but here we do substitution method. So ax plus b whole to the power of n is nothing but ax plus b whole to the power of n plus 1 by a. By n plus 1 by a. Dx by log of ax plus b by a. E to the power of ax plus b dx is equal to e to the power of ax plus b by a. Because this a factor is numeral, this is not x. So otherwise e to the power of ax is what? E to the power of ax into a. Ax differentiation is a. So I am multiplying this. If I differentiate this, what I am getting 1 by a into e to the power of ax into a. Into a get cancelled. I get the same thing. e to the power of b is also constant. So e to the power of b by a into e to the power of ax into a. A get cancelled, e to the power of b into e to the power of a, same. The differentiation of c is 0. So we are getting left hand side. So here also a to the power of bx plus c. So a to the power of bx plus c plus log a by b. So we should be able to understand the multiplicator before x, this numerator. This will come in the denominator. Sin of ax plus b. Sin of is minus cos of ax plus b by a. Okay. Now similarly here some are given. Same principle are given. Tan of ax plus b dx. You know tan integration of tan theta is log of cos ax plus b. 1 by cos ax plus b into sin ax plus b by a. Similarly cot log of sin ax plus b by a. Secant ax plus b. We know secant log of secant x plus tan x by a. Integral secant ax plus b. You see integral secant x is also can be written as log of secant x plus tan x, also can be written log of tan 45 plus x by 2. Both are same. This one and this one is same because integral secant x. So integral secant x can be written as log of secant x plus tan x, or it can be written as log of tan 45 plus x by 2. Similarly, integral of cosecant x can be written as log of cosecant x minus cot x by a, or it can be written as log of tan x by 2. Simply. This is mod. Always log is under mod. So you should have this extra knowledge that in place of this, you can use wherever possible log of tan 45 plus x by 2. This is tan x by 2. You see, I am writing here tan 45 plus x by 2 is tan a plus tan b by 1 minus tan a tan b. So 1 plus tan x by 2 by 1 minus tan x by 2. When I simplify it, cos x plus sin x by 2 by cos x by minus sin x by 2. That is 1 plus sin x by cos x. That means secant x plus tan x, same as secant x plus tan x. So this is only represented in a trigonometric form. So this is explanation for these two common. Similarly, we get tan x by 2. So let us see some special examples of some cases of example. Integral sin to the power of 4x by cos to the power of 6x dx. So this can be written as tan to the power of 4x into secant square x. So this is secant square x is the tan x derivative. So tan to the power of 5x by 5. Tan to the power of 5x by 5. If I differentiate it, 5 tan to the power of 4x is to get cancelled. Into tan x differentiate is secant square x. So I am getting, if I differentiate it, I am getting this. So tan, otherwise you have to put tan x is t. So tan to the power of 4x is t to the power of 4. So secant square x dx is dt. Secant square x dx in place of dt I will put dt. Tan to the power of 4 I will put t to the power of 4. So t to the power of 5 by 5. So this is tan to the power of 5x by 5. So now integral dx by a sin x plus b sin x dx. Dx is already given. Okay. Integral dx by a sin x plus b sin x. So let this is a b. So let this be r, let this be theta a. So a is r cos a, b is r sin b, a is r cos a, b is r sin a. So a square plus b square is r square. So if I use this simplification conversion, then dx by a sin x will b sin x can be written as dx by r into sin of x plus a. Because a is r cos a, so sin a cos b plus cos a sin b, sin of a plus b. Dx by r into sin of a plus b. So 1 by r if I take up, this is cosecant x plus a. 1 by r log cosecant x minus cot x plus c. So or tan x plus a by 2. See how I have proceeded here. It is given that a is r cos a and b is, this is what we have substituted, and we converted this into a single sin a plus b form. So a two forms is converted into sin a plus b by r cos a and r sin a. So this is a trick here to convert. Let us see. Integral x square by square root of x plus 5 dx. Only one square root. So let us see this. X square by square root of x plus 5. So let us put x plus 5 as t. So automatically this becomes root t. So dx is equal to dt. X is equal to t minus 5. I am substituting here. X square is t minus 5 whole square dt by root t. So when I am simplifying, dividing with root t, I am getting difference. So t to the power of 3 by 2. T to the power of 3 by 2 integration, t to the power of 5 by 2 by 5 by 2. So 2 by 5 t to the power of 5 by 2. 10 root t is equal to 10 into t to the power of 3 by 2 by 3 by 2 minus 25 into 2 root t. So this in front of t, I am putting x plus 5. This is my answer. So here in solve, always let us assume to put this as t. The denominator we have to convert into a reasonable convert. Both we are converting into same t. So same example. Here is 1 minus x square. Here it is given x is between minus 1 and plus 1. So I can put as sine theta. I can put as sine theta. So this is sine squared theta by cos theta. Integration of sine squared theta by cos theta. Dx is cos theta d theta. So these two are getting cancelled. Integral sine squared theta d theta. This we can write into cos 2 theta format. 1 minus cos 2 theta by d theta. This is simple. Half into theta by minus sine 2 theta. So you submit in place of theta. Theta means a. Here I am putting theta is difficult to type. So a is easy. So half sine inverse a minus half 2 sine a cos a plus c. So I am converting this half sine inverse here. Sine inverse x. A itself is sine inverse x. Plus 2 into sine a is x. What is what? Cos a. Sine a is x. Cos a is root of 1 minus x square. So how I have proceeded here? X square by square root of 1. I know square root of 1 minus x square will get me sine inverse x. But I have to simplify x square also. Because the second method. Suppose I am adding 1 and divide minus 1. So 1 plus x square minus x square. So this I can write 1 by square root of 1 minus x square minus of 1 minus square by square root of 1 minus x square. So this is directly sine inverse x. This is minus this 1 minus root x square will come here, root of 1 minus x square dx. So again, this I am using in UV formula. This is UV formula. So in under UV formula, x root of 1 minus x square plus integral x into 1 by 2 root 1 minus x square minus 2x dx. So this is again x square 1 minus. So these two are same. This goes to the other side. So 2 half will come here. Half sine inverse x minus x root of 1 minus x square. Same thing is coming here. Half sine inverse x minus half x root 1 minus x. So we can use any method. This is slightly cumbersome method. This is slightly cumbersome method. If you put x is sine a, it is more easier method. Okay. Let us proceed. Find integration of x by square root of 1 minus x dx. So root of 1 minus x dx. So I am putting x as sine square theta. Because 1 minus x dx, I want this under root remove. So x is sine square theta. It is given that x is between 0 to 1. So sine theta is, it will go to minus also, but sine square theta is always plus. So 0 to 1. So if I put substitute this, I will get answer. Otherwise, second method is what? I am adding 1 plus 1 minus 1 here. So if I put 1 minus 1, 1 by x minus 1 minus square root 1 minus x. So this become root 1 minus x minus 2. So minus 2 by root 1 minus 2 root 1 minus x minus integration of root 1 minus x. So this is divided into two parts, 1 by root x minus root x. So this 1 minus x by root 1 minus x becomes root 1 minus x. So 1 by root x can be written as 2 root x. Minus is there, so minus is 2 root x minus integral of root of 1 minus x is 1 minus x whole to the power of half. So 1 minus x whole to the power of 3 by 2 by 3 by 2 into minus 1. So minus into minus plus. So this is the answer. So we can get this way, or we can get putting sine square theta. By putting sine square theta, this becomes cos theta. X becomes sine square theta, integral sine square theta by cos theta. We can solve this problem accordingly. Let us see, this solution is shown in the textbook. This is another method. Integral dx by a square plus x square. We have just seen dx by a square plus x square. Root. If this root is not there, this is tan inverse x by a. So the root is there, we have sin h inverse x by a. Here let us assume x is equal to a sin h theta. Why I am putting h theta? Because I know 1 plus sin square h theta is cos square h theta, cos h square theta. Because so I have to convert this into cos h square theta. Let x is a sin h theta. So dx is a cos h theta. So this becomes integral dx is a cos h theta by this becomes a cos h theta. Both get cancelled. So I am getting answer is theta. What is theta? X by a sin h inverse. So x by a sin h inverse theta. So sin h inverse x by a. So here, but since a square plus x square is there, we have used sin h theta. So because 1 plus sin square h square theta is equal to cos h square theta, under root becomes cos h theta. They two get cancelled. So this is a is not here. Sin inverse x by sin h inverse x by a. So you remember, if it is root of a square minus x square, we have sin inverse x by a. Since it is root of a square plus x square, sin h inverse x. Similarly, our alternate answer let x is a tan a. So we get a tan square 1 plus tan square a secant square a. So when x is a tan a, dx is equal to a secant square a dA. So when I am substituting here, dx a secant square to a by a secant a dA becomes integral secant a dA. What is integral secant a dA? Log of secant a plus tan a plus c. Log of secant a plus tan a plus c. So we are converting, when I am taking a as secant a and a as x is equal to a tan a. So in place of secant a, I have to put the tan a is x by a. This is by a x by a. Secant a is root of a square plus square by a. So this is the answer. Both are correct. So this is log x plus square root of a square plus square by a, or 1 by a sin h inverse x by a. 1 by a is by a. Okay. Similarly, dx by square root of x square means a square root. That means cos h inverse x by a. Dx by square root of x square minus a square. Here we put log of x plus square root of x square minus a square by a plus c. If x is greater than a. If x is less than a, minus log of minus a square root of x square minus a square by a. You can assume here a as cos h theta, because we got x is a cos h theta. So cos square theta minus 1, it becomes sin square h theta. This is sin h theta. So here is sin h theta. Dx is a sin h theta. Both are getting cancelled. We get theta. So cos h inverse x by a plus c. So we should be able to distinguish between cos h inverse, sin h inverse, and log of x plus square root of x square minus a square by So let us continue some more complicated problems of integration from the subject. Okay. So we have done up to this. Let us understand what is substitution guide. See, the purpose of substitution is either to come out of square root easily and to make it my work simplified. See, if the case is a square plus x square, root of a square plus x square, 1 by square root of a square plus x square. So we will put as either tan theta because it becomes secant square theta. A square when it comes out become secant square theta, under root it will come out as secant theta. Or you can put at a sin h theta. What is a sin h theta? So this becomes a square sin square h theta. So 1 plus sin square h theta is equal to cos h square theta. Because we know cos square theta minus sin h square theta is equal to 1. So sin h square theta going to other side, it becomes 1 plus sin h square theta. So this becomes cos h square theta. When it becomes minus, we'll put cos h theta. So a square cos h square theta minus 1 is sin h square theta. So we have to use this cos square theta minus sin h square theta is equal to 1. And we have to use cos square theta plus sin square theta is equal to 1. Whenever minus is given, we use sin theta. Whenever plus is given, we use sin h theta. Whenever x square is there in the beginning, because sin square theta minus 1 is not cos square theta. 1 minus cos square theta is sin square theta. But sin square theta minus 1? No. Then cos h square theta minus 1 is sin h square theta. So these three places, either we have to use sin theta cos theta, or sin h theta, or cos h theta, depending on this. And of course, tan square theta and secant square theta. If it is x square minus, I have to put secant square theta minus 1. I'll get tan square theta. If it is a square minus x square, I have to put tan square theta. A square plus x square, I put tan square theta. X square minus a square, secant square theta. So we have to readjust ourselves with respect to our formulas. So any such thing in the bracket, let us put as either t, or we can put t square also, so that this will go outside. If x square plus a square is t square, so then when I replace this as t square under root, it will become t. So my work is simplified. Similarly here, if you see 2x is there in the top, that means what? There is a derivative of x square. So I can simply log a square minus x square of minus, because 2x is already there. We have to see the problem itself. Otherwise, we can put x is equal to a tan theta. In this case, a square tan square theta. This case is different. These two are log of a square plus x square or x square minus x square. This case, a square minus x square by a square plus x square. This also can be converted into x is equal to a tan theta. This becomes 1 minus tan square theta. That means sin square theta by cos square theta. Cos square theta minus sin square theta by cos square theta. This is 1 plus tan square theta secant square theta. Secant square theta and cos square theta of the above one will get cancelled. So we will get cos square theta minus sin square theta as cos 2 theta. So it will be useful to us. So based on the requirement, this is a special case. We have not seen its application and we have to use. Here you see, instead of squares, it is singular given, a plus x, a minus x. So we need some square here. So cos 2 theta is 2 cos square theta minus 1 or 1 minus 2 sin square theta. So in that case, this a will come, it becomes 2 cos square theta minus 1. So like that, 1 minus 2 sin square theta. So sin theta by it will come. So you have to use this. Suppose x I put a cos 2 theta. What becomes minus a cos a into 1 minus cos 2 theta. 1 minus cos 2 theta can be written as 2 sin square theta. Because cos 2 theta put 2 sin square theta. So it will become sin theta. Root will be going out. So we have to use this cos 2 theta. We are having square automatically. Instead of t square, I put cos 2 theta. Also this root will go out. This is a special case. You have to see this application. This is 2x minus x square. X into a into 1 minus cos theta. Suppose 2a into 1 minus cos theta, 2a square into 1 minus cos theta minus 1 minus cos theta whole square. So again, we know 1 minus cos theta can be written as 2 sin squared theta by 2. So root will go out. So like that, wherever this tan square theta, cot square theta, minus x means I can put sin square theta. X is equal to a sin square theta. Finally, my requirement is what? My requirement is I should come out of the root. Suppose a sin square theta. This is a into 1 minus sin. Here x is square, so I put sin theta. Here x, I put either sin square theta or cos 2 theta. Both are I can choose. It is x only. It is not x square. So I put here sin. Suppose it is given only 0 to 1 plus. So I can use sin square theta. Sin square theta is always plus. So like that. So here also, because see x is in the beginning, x minus a, so secant square theta minus 1. Cosecant square theta minus 1. So we can use. So depending on the x position, whether it is minus x or plus x, we have to use secant theta and cos sin theta. So this is just a guideline how to use for substitutions for complicated integrations. Let us see some examples on these substitutions. Let us see. Log x whole square by x dx. You know, 1 by x dx is a differentiation of log x. So this is log x whole cubed by 3. Log x whole cubed by 3. When we differentiate it, 3 log x whole square into 1 by x dx. So this already 1 by x is given here. So I can simply cube by 3. Of course, plus c. Okay, let us see this one. 1 by 8 plus 2. This is in the form of 1 by a square plus b square. A square plus x square. So this is a square plus x square is tan inverse. This is tan inverse. So let us see 1 by, so I am taking 8 outside. So 1 by x by 2 whole square. So this is in the form of 1 by 1 plus x square is the tan square. Tan inverse x by 2 by x by 2. So tan inverse x by 2 divided by 1 by 2. 1 by 2 means into 2. So this get cancelled. So 1 by 4 tan inverse x by 2 plus c. This is also 2 by root of 25 plus a. This is also again a plus x square. So if I take 25 out, 9 by 25 is 3x by 5 also is again tan. This is x square. Root is there. So this is not tan inverse. Root is there means I have, if it is minus, I have sin inverse. Since it is plus, I can use sin h theta. So sin h inverse. So what is becoming? 1 plus 3x by 5 whole square. So this is sin, if I put sin h theta, I'll get 1 plus sin h square theta is cos h square theta. Like that. So dh theta is sin h theta, dh theta is to cos h theta, d theta. Though both cos h theta is getting, it is becoming integral theta. So 2 by 5 sin h inverse 3x by 5, 5 by 3. How we got this? Let us see this example with sin h substituting as sin h theta. Okay. Let us see this example. Let 3x by 5 is equal to sin h theta. Then if I differentiate 3 dx by 5 is equal to cos h theta. So dx is equal to 5 by 3 cos h theta. Okay. Now 1 plus 3x by 5 whole square under root is equal to under root 1 plus sin h square theta. So we know cos h square theta minus sin h square theta is equal to 1. So if it goes this side, 1 plus sin h square theta is equal to cos h square theta. So this becomes cos h square theta under root, that means cos h theta. So if I substitute integral dx by square root of 1 plus 3x by 5 whole square, this becomes integral 5 by 3 dx we know, cos h theta. This is we know, again cos h theta. Both are get cancelled. So this becomes 5 by 3 integral d theta 5 by 3 theta. Let's see. So theta we know, theta is 5 by 3 cos h inverse 3x by 5. So the same thing has been given as formula. The same thing has been given as formula that if you have this 1 plus x squared, I'll put sin h inverse 3x by 5 by 5 by 3. By 3 by 5 becomes into 5 by 3. So when we simplify it, we'll get 2 by 3 sin h inverse 3x by 5. So this is the formula. So how I am doing? 1 by 2 by 5 I am taking outside. So it will become 9 by 25. So 3 by 5x. So 1 plus x square. This is sin. This is not telling me tan inverse because root is there. If it is root is not there, then it is tan inverse. If it is root is there, that means it is now either sin inverse. If it is minus, sin inverse. If it is plus, sin h inverse. Similarly, root is there and x square minus 1. Here I use cos h theta. So because cos square theta minus 1 is sin square theta, root of sin square theta becomes sin h theta. Above also d of cos h theta is sin h theta, d theta, both get cancelled, theta will remain. So cos h inverse 3x plus c. Okay, now let us see. Integration of sin mx, sin nx dx. We know sin a sin b is equal to minus of cos a plus b minus cos a minus b, 1 by 2. So if I distribute, we'll get 2 cos thetas. So you know integral of cos is sin of sin m plus nx by m plus n. Cos of which is sin of m minus x by m minus n. So half into plus c. So what we have done here, we have split into 2 integrable forms. Here same sin x, sin 2x, sin 3x. Here what we have done, sin 2x, 2 sin x cos x, sin 3x, 3 sin x minus 4 sin cubed x. So when I multiply this, I am getting 3 different. I am using cos x here, cos x. So 2 sin square x into 3 sin x, 3 6 sin cubed x cos x. Again 2 sin square x minus 4 sin cubed x. So 8 sin to the power of 5x cos x. So the cos x is the derivation of sin x. So I can put sin to the power of 4x by 4. Here sin to the power of 6x by 6 plus c. So I can use this or second method. This is a second. This is one method. We can do in many ways. No second method used in textbook. Again, you do it in a splitting form. Sin a sin b is equal to minus of cos a plus b minus cos a minus b, and then we'll get cos a sin b. Because suppose these two I have used, I'll get cos a plus b, cos a minus b. Then again with sin 3x, cos a sin b. So or cos a cos b, we can use 1 plus of cos a plus b plus cos a minus b. So using these formulas by splitting, I am getting in terms of cos 6x, cos 4x, and cos 2x. So both are okay. This is an easier method because I am using cos x as a formula of differentiation of sin x. Now let us see problem number 16. Integral sin x by sin of a plus x. So here all such problems we know a plus x I am taking as t. So dx is dt. So what does this become? This becoming sin of t minus a by sin t. Sin of t minus a can be written as sin a cos b minus cos a sin b by sin t. So when I simplify it, sin t get cancelled, cos a is remaining, integral of cos a dt is t minus, here I am getting tan sin a will be there, and cos t by sin t. Cos t by sin t is log of sin t plus c. So in place of t, I have to put a plus x. So once I differentiate this, I'll get same answer. See, I am differentiating this. Cos a minus sin a by sin a plus x. So here I am differentiating a plus x into cos a. When I differentiate, what I am getting? X is becoming 1, so cos a. This becomes sin a into log of sin plus a plus x is 1 by sin a plus x into 1 into sin a plus x differentiation cos a plus x. Once I simplify it, I am getting sin x by sin a plus x, which is the given expression. So we can, if you have time, we can have a cross check also whether the answer is, when you get a typical answer, we should be able to cross check also. Like log of x plus square root of x square minus 1, log of x plus square root of x square plus 1, all such things we can have cross check. Okay. The denominator is having sin a plus x. It is this denominator sin a plus x. That means some log of sin a plus x should come. So answer should contain log of sin a plus x. This is already containing, see, log of sin a plus x. But with some plus or minus to simplify it. We have to simplify it. Okay. So log of sin a plus x will be coming there. Here also same. Tan inverse x by a will be coming here. So basic will come, but to simplify, we have to use methods. Next. Now, second, this we are doing 6B, second series. So this first series is over. 215, 16 is the first series. Some more complicated problems. 3x square minus 4x dx. You know, 3x square, when I differentiate it, I am getting 6x. So I am having x here. So I can use 3x square minus 4 whole square by, or is this separated? See here, 3x square minus 5 whole square by 2. I'm taking whole square by 2, and this is 6x. I am having only x here by 6. So this is the method also can be done, or you expand this. Expand this also will get same thing, or we can directly use it because there is a f dash x is here. So 3x square minus 4 whole square by 2 into 6x is, x is there, so by 6 plus c. So if I expand this, I am getting 3 by 4 x to 4 minus 2x square plus c, same as this. Here what we have done, 3x square into x is 3x cube minus 4x. So this is 3x to the 4 by 4 minus 4 x square by 2. So this is easy method. This is easy method. Expansion is easy method. This is slightly complicated, but we should have a knowledge that both processes are okay. We should be able to identify this is f of x, f dash x. Second is it secant square x into 1 plus tan x whole cubed dx. Secant square x into divided by 1 plus tan x whole cube. So we can say this 1 plus tan x whole cube. What is the tan x differentiation? Secant square x. So we have f dash x by 1 plus tan x whole cube. So this can be minus 1 by 1 plus tan x whole square minus 1 by 1 plus tan x whole square by 2. Because let us see this. integral secant square x by 1 plus tan x whole dx. I am putting 1 plus tan x as t. So secant square x dx is equal to dt. So this whole form will become dt, and this is t cube. So integral dt by t cube. Integral dt into t to the power of minus 3. So when you do is t to the power of minus 3 plus 1 by minus 3 plus 1. So that is t to the power of minus 2, 1 by minus 1 by 2 t square. Minus 1 by 2 t square. That is minus 1 by 2 into 1 plus tan x whole square. So same thing we can see here. So minus 1 by 2, 1 plus tan x whole square. Similarly, the third one, integral x square by square root of 1 minus x to the power of 6. So if this is making 1 minus x cubed whole square, x cubed whole square, for x cubed we have 3x square here, 1 by 3 into x square. So this is f dash x. So this is sine inverse x cubed by 3. Because this is x cubed whole square, root of 1 minus x cubed whole square. For x cubed, we have a x square supporting in the numerator. Of course, there is a dx here. Should have dx here. Okay. So let us say integral e to the power of x into 1 plus x by cos square x e to the power of x dx. See, x e to the power of x dx. Let x e to the power of x d is equal to t. X e to the power of x is t. Then what is the differentiation of this? E to the power of x plus x into e to the power of x dx dt. So is a difference. This is dt. So integral dt by cos square t. This is becoming cos square t. So the top we are getting dx dt. See, this is e to the power of x into 1, e to the power of x, x, e to the power of x, x, e to the power of x. So basically, x e to the power of x function, this is f dash x. So we'll say minus 1 by cos x e to the power of x. Cos square t can be written as dt by cos square t. That means dt secant square t. That is tan t. Secant square is tan t plus c. Tan of x e to the power of x plus c. If I put minus 1 by cos x e to the power of x, I should get sin x e to the power of x also on the top, which I am not getting. So this cannot be minus 1 by cos e to the power of x because cos derivative is not there. It's only this function derivative is there. So that means this is secant square t dt. That means tan t tan x e to the power of x plus c. Okay. Now we go to next one. Integral dx by x log x. X log x is in the derivative. So log x, we are having 1 by x is the derivative of log x. So this becomes log of log x. So when you derivate it, 1 by log x into 1 by log x into 1 by x. So integral cot x dx. Cot is log cos x, log sin hx. 1 by sin hx into cos hx. So this is cot hx. Next one. 1 by x plus 3 square root of x plus 2 dx. Let it, all such cases, we have to come out of the root. Both are under denominator. Let root of x plus 2 is t square because I am taking out this root by selecting t square. Then what is x plus 3? So t square. Then what is dx? Dx is equal to 2t dt. So integral 2t dt by t square plus 1 into t. X plus 3 is t square plus 1. plus 1 both sides we have added. So 2t by t square plus 1 into t. When I separate this, 2 by 1 plus t square, 2 by 1 plus t get cancelled. 2, this is like tan inverse t. So 2 tan inverse t plus c. Wherever for t, I have to use root of x plus 2. So such problems, we have to choose root x plus 2 as t square. So we have to come out of root by somehow. That's why we have used t square here. Same thing here, substitution. We are using some square here to come out of the root. See the problem number 31. 1 by 1 plus sine 2x dx. So let us use sine 2x as 2t by 1 plus tan square x. 2 tan theta by 1 sine 2 theta is equal to 2 tan theta by 1 plus tan square theta. So if I use this 1 by 1 plus sine 2x can be 2 tan theta by 1 plus tan square theta, then this is becoming secant square x by 1 plus tan x whole square dx. Because 1 plus tan square will come here, 1 plus tan square x plus 2 tan x. This is 1 plus tan x whole square. And this 1 plus tan square becomes secant square x, it goes to the numerator. So secant square theta is tan x differentiation. So we'll say this minus 1 by 1 plus tan x. Minus 1 by 1 plus, if I differentiate it, it becomes 1 by tan x whole square into secant square x dx. So this is the way we did this. What is the second method? This is slightly a tricky method to use 2 tan theta by 1 plus tan square theta, converting it into simple f dash x by f of x. Suppose both sides I am multiplying with 1 minus sine 2x. This is 1 plus sine 2x. I am multiplying 1 minus sine 2x. Here also 1 minus sine 2x. So 1 minus sine square 2x is cos square 2x. So we am separating 1 by cos square 2x is secant square 2x minus integral of sine 2x by cos square 2x. So integral secant square 2x is tan 2x by 2 minus this is cos square 2x differentiation is sine 2x. So minus 1 by cos 2x, 2 cos 2x. This becomes minus 1 by cos square 2x into cos 2x is sine 2x into 2. So minus 1 by 2 cos 2 plus c. So this is also a probable correct answer. This is one method, this is another method. If we simplify this, we may get same thing. But we can use sine 2 theta is 2 tan theta by 1 plus tan square theta. And to convert into an integrable form, f dash x secant square x is tan x f dash x. So 1 by tan x is like dx by x square. So minus 1 by x. This is second method. We'll do conjugate method. We do 1 minus sine 2x by 1 minus sine 2x is a conjugate standard method. And we separate the brackets. We are getting same here. Okay. Let us see another problem. Integration of 1 plus x square by 1 plus x to the power of 4. So we do not have any direct method here. It is in this form. A square x square by a square minus x square. Here it is here. This is not none of this form. Here 2x by a square by 6 square. Yeah, this method. A square x square by a square x square. So here I am taking out x square out. So this becomes 1 plus 1 by x square. Here also I am taking out x square. So this becomes x square plus 1 by x square. X square get cancelled. So this becomes 1 plus 1 by x square plus 1 by x square. Now it is easy. I can put x minus 1 by x as t. Why I am putting x minus 1 by x? I can put x plus 1 by x also as t. But in that case, I am not getting what is dx here? Dx plus 1 by x square is dt. Here I am getting, if I put x plus 1 by x, what is the dx will become 1 minus 1 by x square dx is equal to dt. But in top I am having 1 plus 1 by x square. So I have to get 1 plus 1. So if I put x minus 1 by x, 1 plus 1 by x square. Because the differentiation of 1 by x is plus minus 1 by x square. So minus into minus plus. So you get x plus 1 by x. So my numerator is matching with my dt. So x minus 1 by x, if I am putting t, so what is the squaring? T square is 1 by x square plus 1 by x square is t square plus 2. So this becomes dt by 2 plus t square is the tan inverse t by root 2. So I have to substitute value of t here. So you understand why I have taken x minus 1 by x? Because I want in the numerator dt. So if I put x plus 1 by x, this is coming, dt is coming 1 minus 1 by x square dx. But it is 1 plus 1 by x square. So we have to slightly adjust what I have to take t. In both the cases, I am getting x square plus 1 by x square. Because a square plus b square minus 2ab or plus 2ab. So plus 2 or minus 2 does not matter. Okay. We go to next one. Integral sine 2x by a plus b cos x whole square. Let a plus b cos x be t. All such cases, now we will go straight away with that. Let us assume this as t. So then what is t? dt is equal to minus b sin x dx. Minus b sin x dx. And what is cos x? Here, a goes here, t minus here by b. So here sin 2x, I am writing as 2 sin x cos x by a plus b cos x whole square dx. So 2 minus b sin x dx is dt. So 2 into minus dt by b. So in place of cos x, I am using this t minus a by b. And this whole square is t square. So if I take out the constant terms, t minus a dt by t square. I can separate this 1 by t minus a by t square. So 1 by, this is t by t square becomes 1 by t minus a by t square. 1 by t is log t. A by t square is minus a by t. So 1 by t. So in case of t, I am using, because the logarithm always under mod. Plus c. See here. So if I take this in the bracket as a t and substitute all others in terms of t, I am getting a simplified expanded form integral t dt by t square. Dt get cancelled. Integral dt by t minus integral a into dt by t square. This is dx by x square. So minus 1 by x. So minus into minus plus becomes a 1 by t. 1 by t. Here also minus is there. So this becomes total minus. This minus into this plus into minus minus. This is of course minus. This should become minus here because the integration of this is minus 1 by t. Minus to minus plus 1 by t. Plus into minus minus. So this has to be minus. Minus, and you have 2a here. Okay. Now 38 problem. See, 2b square we have taken out. Integral t dt, integral 1 t by 1 by t is log t. So minus 2b square we have taken out. This is 2b minus 2b square is been taken out. So log t. Here also into minus 2b square. B square we start cancelling. Minus 2 into minus 2a. So it becomes plus. So already minus 2 is taken, minus of minus becoming plus here. Anyway. Here b square is missing. Because if you see here, integral a by t square minus of integral a by t square becomes a by t. A by t into minus 2 by e square. So minus 2a by b square into bottom t. Okay. Now let us see 38. Integral of secant x by secant x plus tan x whole square. So we can write as I am multiplying both sides by cos x. Secant x is 1 by cos x. So I am multiplying by another cos x. Cos x by cos square x into secant x plus tan x whole square. So cos x by, if I take it out, secant x outside, secant square is cos square is getting cancelled. So 1 plus tan x by secant x. What is tan x by secant x? Sin x by 0. So 1 plus sin x whole square. So this is sin x differentiation is cos x. So it can be written as minus 1 by 1 plus sin x plus c. But the textbook what we have done is secant x. I have multiplied both by secant x plus tan x in the top and bottom. Secant x into secant x plus tan x by secant x plus tan x whole cube. So this we know if this is x cubed, what is the differentiation of f dash x? This is secant x into secant x plus tan x. So this minus 1 by whole square. So this will minus 1 by 2 into secant x plus tan x whole square plus c. This is also correct. This is a different form. But answers are different. But both way are possible. So here I have multiplied by cos x by cos x. Whether it is cos x by cos x allowed or not, we have to see based on the x. But otherwise, this is the correct method. Secant x tan x, I am multiplying both sides. So this is f dash x of secant x plus tan x. So this is dx by x cubed. Dx by x cubed. That means minus dx 1 by 2 x squared. To x because they are getting different answers. So this may not be correct. This is the correct step. But this is also one way of doing it. See, I take out secant x from here. So from the square, secant x comes out secant square x. Cos square is secant square is getting cancelled. So 1 plus tan x by secant x. Sin x by cos x secant x will cancel. So 1 by sin x whole square. So 1 by minus 1 by 1 plus sin x. Because this is differentiation of, let us differentiate this. So this becomes 1 plus sin x whole square. Minus into cos x dx. Say. Okay, both are okay, but this is correct answer. Let us go to other one. Integral dx by a square sin square x plus b square cos square x. So I want this integral form. So what I am doing is I am taking cos square x outside. So this is a square tan square x plus b square. So 1 by b square, I am taking this b square also out. Integral dx by cos square x is secant square x into 1 plus tan x whole square. So this is a differentiation of tan x. So we can say this is tan inverse a by b tan x. Tan inverse a by b tan x by the multiple tan x a by b into secant square x dx is already there. So this we have converted into f dash x by 1 plus x square. F dash x by 1 plus x square. Of course, these numeral terms we have taken into denominator. So this is tan inverse fx. Tan inverse fx. plus c. So let us see 40, problem number 40. Integral dx by sine x minus a sine x minus b. So how to proceed this? Sine x minus a sine x minus b. Suppose now we are multiplying both sides by sine b minus a. So sine b minus a is a numeral term. So b minus a can be written as x minus a and x minus b. X minus a minus x minus b. So this is sine a minus b, sine a cos b minus cos a sine b. When I simplify it, sine x minus a get a cancel. I'm getting here cos x minus b by sine x minus b, cot x minus b. Here sine x minus b getting cancelled. So cos cot x minus a dx. This we know. Integral cot x minus b is log of sine x minus b. This is log of sine x minus a. Of course, the minus will come here. So when I do log of a minus b is log a minus log b, log a by b. Log a by b. 1 by sine is cosecant. So here there is a two tricks are involved. One is how to convert this into a integrable form. So I want these two to be separated. Suppose these are partial fractions, 1 by x and x cube square. I can put a by x plus b by x. So I can do partial fractions. But here partial fraction is not possible. I have to somehow separate these two. Partial fraction is not possible. So what I have used is, I have in the top itself also I brought x minus a and x minus b into picture. Sine of x minus a, x minus b into picture with a sine b minus a. If it requires sine a minus b, I can put sine a minus b also, no problem. Sine b minus a. So this is sine a cos b minus cos a sine. So I am getting now these two are separate. So this is a trick we have used here. Okay. Let us see same type another problem. Same I have used here again sine a minus b, sine a cos b minus cos a sine b. Again here in case of cot I am getting tan. So log cos x minus b, log cos x minus a. So same type is the same typical type. So once we know this trick, to separate this, I need here also some cos x minus a, cos x minus b. So I used this method. Okay. Hello students. Now we have completed chapter 6b, section 2 problems. Now we'll see section 3 problems. Okay. Let us see. First problem. Integral sine 2x by a cos square x plus b sine square x. You see, if I differentiate the bottom one, a cos square x becomes a into 2a cos x. Cos x differentiation is minus sin x. So this is minus sine 2x. 2a minus sine 2x. This is 2b sine 2x. 2b sine x into sine x differentiation cos x. So we have sine 2x here. So this is almost f dash x. So let us see here. Sine 2x is cos square x. I am converting to sine square x. So everything is coming under sine square x. A plus b minus a sine square x. So this is differentiation of this. So this is log of a plus b minus a sine square x by b minus. This is a b minus a. B minus a is multiplication of sine square x. So by b minus a plus c. So same thing, 1 by b minus a log of a cos square x plus b sine square x. Same thing is coming. So this is in fact b minus a of multiplication. We know log of a cos square x plus b sine square x is coming. But what multiplication for which we have done this exercise? Let us say cot of log x by 1 by x dx. Log x differentiation is 1 by x. Integration of cot x is log of cos x. Integration of cot x is log of sin x. So log of sine log x plus c. So when we differentiate it, 1 by sine log x, sine differentiation is cos log x, log x differentiation is 1 by x. So all are matching, all are given here. If x is not given, then it's a different problem. So this is log of sine log x plus c. Let us see this one. Secant tan x, secant of tan x. It is not secant x tan x. It is not secant x tan x. It is secant of tan x, secant square x dx. If I put tan x t, then become secant t dt. This is nothing but secant t dt. So secant t dt, we know secant is log of secant t plus tan t. So when I put in place of t, log of secant tan x plus tan x plus c. But textbook answer is different. Let us see how it is behaving. Secant tan x plus tan x. I am talking secant x plus tan x. Differentiation of secant x plus tan x. So 1 by cos x. This I am converting into textbook answer. Let us see. Tan x I am talking of a. Secant a plus tan a. Secant a can be written as 1 by cos a. Tan a can be written as 1 by cos a can be written as 1 minus tan square a by 1 plus tan square a by 2. This is a half angle. 1 minus tan square a by 2 by 1 plus tan is one of the form of cos theta. Cos theta is 1 minus tan square theta by 2 by 1 plus tan square theta by 2. And tan theta is equal to 2 tan theta by 2 by 1 minus tan square theta by 2. So here common 1 minus tan square theta is the denominator. So top is 1 plus tan square theta plus 2 tan theta by 2 is whole square. So this 1 minus tan square theta by 2 can be written as a plus b into a minus b. So this square getting cancelled. So 1 minus tan a by 2 by 1 plus tan a by 2. This is nothing but tan 45 plus tan a by 2 by 1 minus tan 45 tan a by 2. That is tan 45 plus a by 2. So a is nothing but tan x. So this is tan 45 plus tan x by 2. This is a textbook answer, but this answer is simple. Log of secant tan x plus tan x plus this is also correct. Okay. Log secant x, log of secant x plus tan x. We know differentiation of log of secant x plus tan x is secant x. When we differentiate this, 1 by secant x tan x into secant x plus tan x. These two get cancelled, secant x is remaining. So this is a differentiation of it. So we have also log of secant x tan x whole square by 2 is the answer. Let's see. Now sine cubed x. Sine cubed x can be written as sin x into 1 minus cos square x. Integral sin x dx minus cos square x sin x dx. Integral sin x we know cos x. Cos square x sin x, this is a differentiation of cos x. So cos cubed x by 3 plus c. But the same thing can be converted into 3x. Same thing, in fact, sin cubed x can be converted into what is sin 3x? 3 sin x minus 4 sin cubed x. We can make sin cubed x as subject, and when we differentiate, we'll get the same answer. This is a textbook answer. So it can be done both ways. So again, cos x, cos 3x dx. Is it cos a cos b? Sin a cos b, cos a sin b, cos a cos b, cos a plus b plus cos a minus b. So half of cos a plus b is 4x. Cos of minus theta is cos theta is cos 2. Simple. This is sin 4x minus sin 4x by 4. Sin plus sin 4x by 4. This is plus sin 2x by 2. So this is the answer. Now instead of cos to the power of 4x dx. Let us say this is cos to the power of 4x can be cos square x. This is cos 2 theta is equal to 2 cos square theta minus 1. 2 cos square theta minus 1. So cos to the power of 4 theta is cos 2x plus 1 whole square. So I am taking cos square x whole square. Cos square x is 1 plus cos 2x whole square. 1 by 4. Because this is, when I expand this, what I am getting, this is 2 cos squared x minus 1. Minus 1 plus 1 can cancel. 2 cos square x whole square is 4 cos to the power of 4x. But here cos to the power of 4x. So 1 by 4 has come here. So again, this I am expanding. 1 plus cos square 2x plus 2 cos 2x. You know 2 cos 2x is 2 sin 2x by 2. That is sin 2x by 4. 1 is x. So cos square x again I am converting into cos 2x format. Cos square 2x is equal to cos 4x plus 1 by 2 because square is not there. So by 2 is coming here. So when I simplify this, I'm getting this answer. So what I have done, cos 2 of 4 I have converted into the linear programs. Either 2x form or 4x form or x. Okay. So let us continue. Integral x root 4x plus 3. All such cases, this x root 4x plus 3, b plus cx, 1 plus e by e to the power of x, a plus bx. You put the bracket as t, 1 minus x. So let us see. 4x plus 3 putting as t. Since it is root is there, I have taken it as t square. Then what is x? X is equal to t square minus 3 by 4. What is dx? Dx is equal to 2t dt. So let us substitute. In place of dx, 2t dt. In place of x, t square minus 3 by 4. Root of 4x plus 3 is t. So when I substitute all, what I am getting? T to the power of 4 by 8 dt minus 3 by 8 t cubed dt. Is easy. T to the power of 5 by 5. This is t to the power of 4 by 4. T cubed 5 by 5. This is what? Second one. This is 3 by 8 t cubed after removing the integral. So when I substitute in place of t, this what is t? T is 4x plus 3. So I am getting 1 by 40, 4x plus 3 whole to the power of 5 by 2 minus 1 by 8, 4x plus 3 whole to the power of 3 by 2. So t is root, t square I have taken. T is root of this. So t by root. So let us see second problem. Here I am taking b plus cx as t. Because whole square is there. Root square, so that will be getting cancelled. So b plus cx is t. Then what is d? C dx is dt. C dx is dt. Integral dx by square root of a square minus b plus cx whole square is can be taken as dt by c, because dx is dt by c, square root of a square minus t square. So this is in the form of square root of a square minus t square. So sin inverse t. This comes as 1 by c sin inverse t by a. Sin inverse t by a comes out, t by a, 1 minus t by a whole square. So sin inverse t by a plus constant. So second method. So I am taking out a outside, dx by a, dx by 1 plus b plus cx by a whole square. This is sin inverse b plus cx by a by c by a. So a getting cancelled. So 1 by c sin inverse b plus cx by a. This is direct without substituting t. I can do direct also. Let us here dx by 1 plus e to the power of x. Let e to the power of x is t. So dx is equal to dt by e to the power of x. That means dt by t. Dx is equal to dt by t. So I am substituting here dt by t 1 plus t. So when I am dt by t into 1 plus t. So integral dt by t minus integral dt by 1 plus t. This is partial fraction. 1 by t into 1 plus t can be written as 1 by t minus 1 by 1 plus t. This is a partial fraction I am splitting up. 1 by t minus 1 by 1 plus t. When I do LCM, it will come 1 by t into 1 plus t. So it is separated in partial fractions. So this is log t, this is log 1 plus t. So log of e to the power of x. So log t minus log 1 plus t plus c. So t is e to the power of x. Log e to the power of x can be written as x. So this is x minus log 1 plus e to the power of x plus c. This is the answer. Similarly here, let us put a plus bx as t. This is, there is no root here, simply square. So I am putting a plus bx as t. So dx is equal to dt by b. And x we have t minus a by b. You substitute x square is t minus a by b whole square into dx is dt by b. This is 1 by t square. When I separate it, I am getting a integrable form. Integral dt integral a square by t square integral to a dt by t. This is log t. This is minus 1 by t. This is t. T minus 1 by t. This is log t. So in place of t, you go back to my substitution. Okay. Now see the other problem. Integral x square by root of 1 minus x. So again 1 minus x I am taking as t square because I don't want this root under the denominator. In place of t here I have taken t because there is no root here. So you have taken t square. So then what is dx is equal to 2t and x is equal to 1 minus t square. You substitute here x square is 1 minus t square whole square by into 2t dt by t. T get cancelled. So we simply it's the expansion 1 plus t square minus 2t square. So this is simply a normal integrable form. So this 1 is t, 2 root of 1 by x, t square is t cube by 3, t cube means 2 to the power of 3 by 2, t to the power of 5, 5 means 5 by 2 because I have taken as t square as 1 minus x. Okay. So with this chapter 6b, 3 of 2b are over. Now we will see one example of additional example. See 1 by sine x into 2 plus cos x minus 2 sin x dx. All in the form of sin x, cos x, sin x. Let us convert them into one single form. So we know sin x, cos x can be written as in tan x by 2 form. So I am putting that tan x by 2 is equal to t. So secant square x by 2 into 1 by 2 dx is equal to dt. So what is dx is equal to 2 into dt by secant square x by 2. Secant square x by 2 is nothing but 1 plus tan square x by 2. So 2 by 1 plus t square dt is dx. So let us substitute here. Dx is equal to 2 by 1 plus t square. Sin x is equal to 2t by 1 plus t square. Cos x is equal to 1 minus t square by 1 plus t square. Sin x is equal to 2t by 1 plus t square. So when we substitute, we get a fractions in the bottom. T into t minus 3 into t minus 1. This is divided between a by t plus b by t minus 3 plus c by t minus 1. When we equate the terms, we are getting these are the 1 by 3 into dt by t, 5 by 3 into dt by t minus 3 minus into dt by t minus 1. So when I do logarithmic fraction. So what this example shows that if a multiple sin x's and cos x are given, you go for tan x by 2. Because all this can be converted into t form. See here, integral x square sin x dx. In this use uv formula x square. Integration of sin x is minus cos x minus integration of minus x into 2x dx. So we have to simplify again x cos x. Here again integrated and derivated. So x square is 2 times derivated. 2x one time here, x one time here. But this is UV formula we will cover in the next session. Here we will see integral x sin square dx. Sin square x can be written as 1 minus cos 2x. So x into 1 minus cos 2x by 2. So this is two form. This we know. This is x square by 2. X cos 2x. Again x cos 2x is defined as again UV formula. Cos 2x integration is sin 2x by 2 minus sin 2x by 2 plus sin 2x. Sin 2x differentiation is cos 2x minus half into differentiation of x is 1. So my sin 2x is minus cos 2x by 2. So this is UV formula. Based on that, we will review in the next part. It's only given an acquaintance of a UV system. Here it is a T system. Whenever sin and cos are given, you can go for tan x by 2. This is not x. Tan x by 2 is equal to t. So to convert them into single fraction. With this, part 1 of integration is over. Part 2 will cover later. So let us do more and more practice and understand the concept of integrations.